Are we live? I think we're live now. Let me make sure that sound is there. Okay. Hello world, it's Siraj and welcome to week 10 of Make Money with Machine Learning. I'm super excited to have you here at the end of the course. It's been quite a ride, hasn't it? Hi everybody. Elliot, Shanawaz, Michael, Kapil, Ravi. Hi everybody, how's it going? I'm very glad to see you here today. We're going to start off with the Q&A and then I'm going to show you two midterms. Let me turn off this volume so I don't hear myself. Okay. I'm going to show you two midterms. So, I can show you things that I really liked about them. And then we're going to look at data privacy laws. And then we're going to look at a special protocol that I've never actually talked about before called Ocean Protocol, which is all about the future of data, the future of training AI models in a secure and private way. And I'm excited to talk about that one. All right, so let's see if we have any Q&As first, and then we'll go right into the material for this live session. Guys, I know I'm gonna miss it too. Well, I'm not gonna miss the live, like doing this. I'm gonna miss you guys. I mean, talking to you like this. Um, Look, in terms of doing more live sessions like this, I'm sure I will. I have a much needed break that I need to take. Um, Maybe for 2 weeks, but I got to get those final grades in first before even that. So break isn't started yet. That's in a few weeks from now, after everybody turns in their final, which I'm super excited about. I hope you guys are as well to turn in the final. So do we have any questions? Any questions about the final, about um, the material for week 10, AI in general? Yes, Shanawaz, the Discord is, like I said, lifetime access. It will always be there. The material is lifetime access. It will always be there. Um, yeah. Any other questions before I get started? I can just dive right into this. Okay, let's dive right into this. I'll make myself smaller. All right. Okay, so the first midterm I wanted to show off, 2 weeks, Kapil. The first final I wanted to show off is this dog classifier by Joshua Galinsky. I hope I'm saying his last name right. Galinsky or Jelinsky. So he's a university student who made this dog classifier, and he created this really cool GIF demo, which we can see right here, of how it works. And you can see that once he types in the user information and the login information, then he gets to the predictions page. He can upload a dog picture, and then it's going to give back the prediction. And the cool part about this is that the payments is integrated really well into this. So I haven't shared this midterm before, but I want to show you some things that I really liked about it. First of all, if we go into the predict function, if we go to predict.js, make sure that this code is visible, make it bigger. You can see that he's using the MobileNet's pre-trained model that TensorFlow.js serves from their server. So he didn't have to download a model himself or do any of that training. He's calling it from the web. This .json file is the trained model. And then, generic predict functions, read functions, and these are all mapped to buttons in the front end. So all of those predictions are going to be returned as a tensor of values, and then it's classified. So now let me show you what I did not like. So if we go to ImageNet classes.js, it looks like he went ahead and hard-coded over 1,000 classes of different dogs and animals in general. So we don't want to do that. There's a better way of doing that. So if we have, well, when I say if there's a better way of doing that, we don't want to encode that as JavaScript. We can encode that as a configuration file, but if we encode it as JavaScript, if let's say we're running on Node or some JavaScript virtual machine, then it's going to add just a little bit to the loading time because it's compiling it as JavaScript. So it would just be better to load it as a configuration file. But overall, I mean, this was a really clean example of using Stripe, Flask, Firebase together. All of the functions necessary are right here in this app.py file. So that's some great stuff. So that's the first one. I definitely want you to check that one out. I'm going to put that in the YouTube comments. So the next one I want to talk about is ReviewRater. So this one by Yash Prakash is super cool. It is a sentiment analysis tool for rating reviews. So you type in whatever your review is going to be, and then it's going to give it a rating like 1 out of 5 stars. And this is a great example of sentiment analysis, but not just any type of sentiment analysis. Like you can go and search sentiment analysis on GitHub, and you're going to find a million examples, but you'll not find a single example like the one that Yash has created right here, because all of these examples are training scripts. But what Yash did was he took that training script and he put it on a server. So that's super cool. I really like that about this one. If we go into model and then we go into clean text vector, there's basically two files that are the main files for this. The first one is this clean text vector.py, which is basically used to clean the data and also convert it into vectors. So the model that he used here is called word2vec. But in order to use that model, he had to pre-process that data. And all of that pre-processing was done with NLTK, which we talked about, I think, during week 3 of the course. NLTK, super useful library. So even though he ended up using a training script for doing sentiment analysis with scikit-learn, he still used NLTK for that pre-processing of those strings. So these Kindle reviews are the training set, and then you can see the training script right here. It's using GenSim, which is word2vec, and then it's able to do all of this semantic similarity right there. So there's a lot of sentiment analysis code in about 300 lines right here in na3.py, which I really liked. And yeah, so definitely check out this sentiment analysis example right here by Yash Prakash. I'll post this one in the YouTube comments as well. All right, so that's it for the sentiment analysis part. Those were the two midterms I wanted to show you. Now what I want to do is since we're at the end of the course, I want to talk about where we're headed with data, data privacy, data science, what the different paths that are going to be available for us are moving forward. So data privacy is not something that's top of mind for a lot of us. We don't really, it doesn't seem necessary for us, but it is necessary because here's this map of global data protection laws. If you go to DLA-Piper-dataprotection.com, you will see it. And it basically has a listing of all of the data privacy laws, all the data protection laws for each country. And if we click on a single country, let's just click on Thailand, I guess, randomly. It's going to show what laws that Thailand abides by in terms of data protection. So this is the 2019 law. So this is what I'm saying, like 27th of May, 2019. This was 4 months ago. This law was enacted. Okay, so that's super new. Now, what are all of the details of Thailand's Data Protection Act? And how should we, as service providers, deal with Thai data, right? How should we secure it? What do they expect of their service providers? Like what should we even do with their data? Now, the red, that's something to be thinking about, right? Now, if we look at the red areas, basically all of the Western nations here are the ones with the heaviest data protection laws. And generally speaking, the amount of connectivity in these places is the highest of any of the world. So what that goes to show you is that Um, these places have the most heavy data protection laws right now, but because they're at the forefront of networked communication technology, this is just going to happen everywhere. So you can expect that this entire map is going to be red. So that means there's going to be a lot of data protection laws in place for people. Like if we look at France, for example, of course there's GDPR, which is like the kingpin of data protection laws. But and GDPR has a lot of different directives, like you have to let the user know that you're going to be using their data. So there has to be like some kind of like binary yes or no agreement statement. You can't do certain things with their data. So there's a lot of uh, landmines here, potential landmines that we want to avoid if we're building any kind of service that uses people's data. And we have to think about ways of getting around that or complying with that. Now, in the last week of the course, I've talked about OpenMind. Now, we all know, or at least are familiar with OpenMind from that content. But what I want to talk about today is something I've never talked about. I don't think I've ever talked about. Maybe I might have tweeted something about this 2 years ago, but I've never made a video on it. It's called Ocean Protocol. And Ocean Protocol is basically a data exchange protocol. And if we look at the roadmap, we can just get a sense for where we are in the development of this protocol. Basically, it started November 2017, and right now, let's see where we are right now. We are at V1 Pacific. So it just launched, like a few months ago. The beta was in April, and now it is the main net. It is built on top of Ethereum, and if you're not familiar, Ethereum is a blockchain network that a lot of apps are built on top of that uses its abilities of data privacy, data security, data ownership, and fast payments. Those are really the key things that Ethereum provides. So it was built on top of that. So what it comes down to is it comes down to a library that we can use to do a couple things with. I mean, there's a lot going on in Ocean Protocol, but it is launched. It is ready to use. If we look at the architecture, we can see that. Let me make sure this is. If we look at the architecture, we can see there's a lot going on here, right? There's three tiers that they call it. There's an application layer, there's a data science layer, there's a protocol layer, and there's a lot of functionality here. So I'm not going to go over every single thing that it does, but I will tell you that what you would want it to do, like a certain use case for this, would be, let's say you upload a web app and it's using AI for, say, sentiment analysis, and you want to get a new data set. Well, what Ocean Protocol has done is they built this decentralized data marketplace where anyone can publish a data set. So you can, upload a data set to Ocean Protocol, and then it's going to give you an address for that data. And what happens is that you can be sure that that data is tamper-proof, that it's secure, and that no one except the person with the private key is going to be able to access that data. Now, how do you know that only the person with the private key is going to be able to access that data? Well, you know that because you have the key for it. So that's the functionality there, right? So it's basically a data exchange protocol that allows you to exchange keys and store data in a way that nobody owns. So the data itself is stored in IPFS, which is a data storage protocol that no one has ownership over. It's a decentralized protocol. Now, the paper right here is quite a long paper. I would definitely recommend reading the paper, just because it's interesting, and it shows you where we're going with this stuff. Like, if we're talking about the future of making money with machine learning, we can imagine an AI, okay, that's basically right now we have a web app and we put it on a server, okay, and that server is on, say, Heroku or it's on Render. But what if instead of uploading it to one place, we can take this AI and upload it to a network like Ocean Protocol where it's split into several pieces and nobody owns it and it's encrypted so nobody can modify it at all. Now, in that way, and let's say the AI is able to earn money as well and to earn data and to make itself better over time. You then have a decentralized AI, a self-improving system that will send you payouts every month, but it doesn't need maintenance. It learns and grows by itself. So that's a really out there kind of concept. It's kind of hard to understand because there's no proof of concept there. But I really want to show you guys like the latest and where I think that these things are going in the future. Trent McConaughey is a great person to follow. He used to work on BigChainDB, which turned into Ocean Protocol, and BigChainDB was supposed to be a blockchain database, which is a great motto, I think, for what they're trying to do. So that's basically the stuff right there. So Ocean Protocol, definitely wanted to talk about that one. And yeah, so those were the things I wanted to talk about here. Now I want to answer some questions. Talking about any piece of advice. Any piece of advice for what to do after this course to improve our skills, knowledge in this AI field? Um, yes, absolutely. So basically, this whole process of that you've been doing these few weeks, um, you have to continue to do that. So besides the studying part, besides um, the implementation part, the curation part is really a lot of the value that I brought to this course, like curating the best learning path. But learning how to do that for yourself is a lifelong skill to know, right? Because I do that for myself. Like, what am I going to learn? What are the resources that I'm going to use? What is the learning path that I'm going to take? Being able to curate that for yourself is something that is going to be incredibly useful throughout your career. And in order to improve your skills, I would say practice creating curriculums for yourself. Like pick a topic and then pick, say, 10, 11, 12 subtopics and an ordering for those subtopics of how to learn a topic. And then compare your curriculum to the existing curriculums on the web and see how it compares. And you want to make sure that it's accurate. And I think that's a really good practice. I want to go into AI research in particular. I'm very happy to hear that. I think anyone can do that these days. Any advice? One way to show course success, if you can show candidates who he referred, who got full-time jobs or started a company, etc., by doing the course. I think so too. Later today, I'm going to release a video of some of the top midterm projects. Some of these students are actually trying to create startups already. They have startups, they have teams, so that's nice. But yeah, I definitely want to add a showcase of the top students on my website. I said that last week, and I will add that, but like way after the course, after the finals have been submitted and stuff. How to improve accuracy in a facial recognition system? OpenFace. OpenFace is the best library there for facial detection in general. All GitHub. I think it's called OpenFace. Yeah. 12,000 stars. Quite a lot of stars. 12,000. That's a lot. How much time do we have to decide what kind of referral we want once and share the web link? Once you share the web link, you'll have about 1.5 weeks. Self-learning backend is done by TF Serving. What is the role of Kafka? I'm confused. Sure. So, okay. So TensorFlow, it's a training and testing library, right? You write ML scripts. TensorFlow Serving is a server architecture that takes TensorFlow and it allows it to perform inference inside of a web app. So there's a whole process that happens here, like versioning, for example. Let's say we have a new version of a model, right? Let's say we have a current version of a model. Let's say it's an image classifier. It's trained on dogs, dog classifier. It's working, okay? It's a 98% accuracy model. And users are uploading their dog pictures and they're asking for inference and it's working fine. Now, as users are uploading their dog pictures, we're increasing the size of our database. And that means we can retrain this model on the nude pictures. And so while this model is performing inference, we're training a new model that's going to have a higher accuracy. When it's done training, we're going to replace that model. And then we're going to keep training again. This process, this continuous delivery process, TensorFlow Serving automates for us. So that's what's great about it. What Kafka does is it's a data stream platform. So it can stream data in real time. So not just as users are uploading dog pictures manually, but let's say there's an API of say tweets that we want every 30 days or every 30 seconds. Kafka will create that streaming pipeline for us. 1 referral per student, Iris. In terms of additional skills, in terms of blockchain, absolutely. Look, I think blockchain knowledge there was a lot of hype around it 2 years ago, and a lot of it died out, but it's still there. It's still a useful tool. And I think the most useful part of blockchain is when it applies to AI. That's really going to be the utility of blockchain. Like, how do we secure data and how do we prove ownership? Those are the two questions that blockchain answers. Like, blockchain provides a provably secure way of authenticating some data as ownership and authenticating that some data has never been tampered with. I think the number one use case, the number one industry is medicine, because patient data is supposed to be super secure, right? There's a lot of laws around that. Yeah. Um, Gopal, at some point I will. Not this live stream, but at some point. I want to keep it related to the material here. What is the best way to perform unsupervised learning using neural networks? Autoencoders are a very popular method. Are they the best way? Probably not the best way. I mean, there's different. If you have a little bit of data, then clustering, k-means, always works well. With scikit-learn, you can just really quickly get some clustering going. With more data, like let's say more than 100,000 examples, autoencoders are a great way to go. How do you start learning new libraries? To be honest, it feels boring to read the docs any other way. Well, how do I start learning libraries? Well, I actually love reading the docs. I'm a weirdo like that. I love reading documentation and I love writing documentation as well. Um, how do you avoid that? I mean, implementation as well. Even looking through the GitHub code, that's considered studying right there. Like, I do that all the time. Like, the great thing about GitHub is you don't even have to download some code base to be able to read it and to um, be able to parse it. You know, but overall, I think it's fun. Like, learning code, it's like it doesn't really get old for me. Zan, I'm sad to hear that you temporarily lost interest in healthcare. I know healthcare is hard. There's a lot of legalities there. The time to make an impact in healthcare is like 10 years. Traditionally, if you wanted to become a doctor, or a medical professional, let's say a doctor, that's 4 years of medical school, 4 years of residency, 2 years of fellowship. If you create a software tool, You can make an impact much faster. Would you refer us for internship in companies, not job, as I am a student? What are the things need to keep ready for referrals? They are full-time job referrals, not internship referrals. You mentioned no more live sessions. Could we at least have some extra office hours for questions we might have? I'll definitely have some. About the final project, please. Hmm. You know what? I mean, I'll be around in the Discord on and off. In terms of a question or any questions, just compile them all and just email them to me, Laura, and I'm really going to try to answer them ASAP. Just hello at Sirajaval. I'll answer them. I can. By this point, I've recognized the students in this course like by name, so like I just give them priority in general. Um, can you guide us on how do we analyze a video? I feel like this. Have you? Are you the guy who keeps asking the same question? No, you might not be. But let me answer it. Analyzing a video, think of a video as a collection of images, right? So convolutional nets are great for image classification. And so if a video is just a sequence of image frames, then we're just going to apply inference using a convolutional network in batches, like maybe 60 batches until we have this overall classification, or at least a time-based classification, what's happening at each marker of the scene. But it's just a convolutional network. And then the hard work is the data pre-processing. Turn the video into a collection of images to perform classification. Aka, yes. Vrushali, do you not have the link to the Git Discord channel? Seriously? On the last week? Guys, give him the link if he doesn't have one. Is OpenFace better than FaceNet? I think so. I mean, I look at like GitHub activity, developer activity on GitHub. And OpenFace has way more, much more. How can we maintain my model? Say after sometimes my model starts performing worse. Transfer learning. So seeding your model with different representations over time can improve its accuracy, especially for computer vision tasks, image classification tasks. And Awesome Transfer Learning is a great resource right here because it's got like so many pre-trained models to use. Right here, Awesome Transfer Learning on GitHub. Boom. All right, so guys, the finals are here, and I'm really looking forward to these finals. Office hours are on Friday. I'm looking forward to discussing more and answering questions about your finals there too. I'm looking forward to grading these finals as well. The midterms were pretty fun to grade, I have to be honest. They're pretty fun to grade. And yeah, it's been quite a ride. I'm looking forward to you guys making some money with machine learning because in the end, that's what this is all about, you know? That's what everything is about. And you know, if even one person or if even one team here has a very successful startup, then that's just like worth it for the rest of my life. It's like a life success. So let's get some successful startups going, guys. I'm going to be sharing the top 5 later today publicly. All right, guys. So that's it for this live stream. MPED, yes, you can have an extension. Well, Zenair, if you guys are making sales and you're really going for it, you know, if it's like really like you're making sales and you're like self-sustaining and you're, you know, profitable, then I can connect you to some capital financing as well. But I need to see something, right? I need to see like this is already a business. You guys just need some capital to grow. Then of course I'll connect you with my venture capital connections, which I have plenty of. So, all right, guys. I love you all. Thank you so much for sticking through this 10-week course. It has been the ride of a lifetime. It's been a learning experience, to say the least. And I'm proud of all of you. I'm very proud of all of you. Okay? So submit your finals. See you in the office hours later this week. And yeah, I'm looking forward to your success. All right? I love you guys. Truly, deeply. I love you guys. All right. Bye, guys.